Morning, and thank you for joining the virtual workshop on proposed changes to BC Energy step code requirements for Part 9 buildings in the City of North Vancouver, the District of North Vancouver, and the District of West Vancouver. My name is Larissa Lensink, and I'm a planner in the City of North Vancouver's Environmental Sustainability team, and I am joined by staff from the 3 North Shore municipalities. I'd like to start by acknowledging that this workshop is being hosted on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations, and we are grateful for and committed to learning from these peoples who steward this land well. Before we get started, we have a couple housekeeping items to go through. So the first portion of this workshop is being recorded and will be circulated following today's session. During the recorded portion, your cameras and microphones will remain off and your name and email will be hidden from other attendees. When we move to the discussion time, we will stop the recording and open the floor for participants to turn on their microphones if they would like to provide comments or questions verbally. If you have issues with your audio during the workshop, you can use your phone to dial in using the number and the meeting code on the screen, which are also in the email invitation. If you have any other technical difficulties, you can email environment@cnv.org. There will be a time for questions and discussion after the presentations. You can submit your questions using the Q&A function, and we will answer them after the presentations, or you can wait until the microphones will be enabled to ask them verbally. Finally, at the end of this workshop, you will be directed on your browser to a survey to collect feedback on the proposed requirements. It should only take a couple minutes to fill out, and we would really appreciate your feedback. So the 3 North Shore municipalities are pleased to be jointly hosting this session for the building community to seek input on proposed changes to Part 9 Energy Step Code requirements. The proposed changes would apply to all new Part 9 residential buildings across the North Shore, including single-family homes, duplexes, triplexes, and some small townhomes, and aim to increase efficiency, comfort, and utility bill costs for residents. We are not proposing changes to our requirements for Part 3 or large residential and commercial buildings at this time.
Sorry, Lisa, do you mind if I just jump in really quick? I just got a note that someone was having some audio issues. I'm just wondering if Anu might be able to suggest a way to resolve that. Got a note that someone's in the webinar but can't hear.
Yes, I can just send out another email. Did this person do this in the Q&A function or feature?
No, it looks like it was someone from just a Teams message we got here.
Oh, okay. I will send you the access code to send them over to the Teams, so you can send it to them in the Teams, so they should be able to dial in with audio.
Okay, thanks.
Great, thanks. So this morning's workshop will cover the background to the BC Energy Step Code and provide an overview of the proposed changes for new Part 9 buildings. We will hear from a guest speaker, Mary McWilliam, about the technical skills required to achieve the upper steps and available training programs. Following the presentations, we will open the floor for questions and discussion about the proposed changes to hear your feedback. Finally, the last 10 minutes of the session, we will cover a new proposed mechanical permit specific to the City of North Vancouver. So just actually before we get started, we'd like to have a quick poll to get a sense of who is attending today. So we'll launch the poll now, and there should be 3 questions for you to answer. And we'll give us a better idea of who is in the virtual room this morning. Okay, it looks like most people have responded, so we can close the poll now and show the results. So we have a good spread, people working across the North Shore, a variety of sectors represented, and lots of experience with step 3 and step 5, which is great. Thank you for participating in that. So the 3 North Shore municipalities share a climate target of net zero emissions by 2050. In the city, natural gas use from buildings accounts for 40% of community-wide emissions, and these figures are similar in the districts of North Vancouver and West Vancouver. Reducing energy use and shifting to low carbon energy sources through the BC Energy Step Code are important strategies in addressing emissions from new buildings and achieving our climate targets. On the provincial level, the province has set clear targets for new construction to be zero carbon by 2030 and net zero energy ready by 2032 in the Clean BC Plan and the Clean BC Roadmap to 2030. These 2 plans recognize the need to both increase efficiency of new construction and transition to low carbon mechanical systems like electric heat pumps in order to reduce emissions from buildings and improve comfort. The primary tool the province has developed to increase efficiency of new construction is the BC Energy Step Code. The Energy Step Code provides a pathway to incrementally increase energy efficiency over time through a series of steps with defined energy efficiency metrics. The Energy Step Code is performance-based and compliance is demonstrated through energy modeling alongside air tightness testing. Local governments can choose which step to adopt and when to move to the next step along the path to net zero energy ready construction. Over time, the province will change the minimum energy step code requirements in the BC Building Code to ensure energy efficiency improves across the province and ultimately achieves net zero energy ready standards by 2032. As of May 1st of this year, the BC Building Code requires that all new Part 9 residential buildings are built to step 3 across the province. The building community on the North Shore has been a leader in achieving high energy efficiency requirements over the last decade. Prior to the introduction of the Energy Step Code, the North Shore municipalities offered a density bonus for high energy efficiency ratings. With the launch of the Energy Step Code, the North Shore municipalities adopted Step 2, which was equivalent to the current standard incentivized through density bonusing. In July 2018, we increased our requirements to Step 3 for Part 9 residential buildings, and builders have been consistently meeting or exceeding these targets for the past 5 years. In July 2021, we introduced a low carbon pathway to incentivize low carbon energy systems, requiring either Step 5 or Step 3 with low carbon space and water heating systems, primarily achieved with electric technologies. The 3 North Shore municipalities have worked closely together to coordinate step code requirements and provide consistency for builders across the North Shore. This sub-regional coordination has been used as a model for other local governments, and the building community that has developed on the North Shore is recognized as among the most advanced in the province. The 3 North Shore municipalities are now proposing to increase our low carbon pathway for Part 9 residential buildings from Step 3 to Step 4, after having had success at Step 3 for the past 5 years. Currently, we require either Step 5 or Step 3 with low carbon space and water heating systems. We are proposing to maintain our approach of offering 2 options, requiring either Step 5 or now Step 4 with low carbon space and water heating systems. These requirements would apply to Part 9 residential buildings, meaning single family homes, duplexes, triplexes, coach houses, and some townhomes, and be effective September 1st of this year. This change is proposed in order to improve energy efficiency of new homes and reduce energy consumption, lower utility bill costs for residents, and increase comfort and resiliency to warmer temperatures. By increasing energy efficiency and moving from Step 3 to Step 4, we will be reducing energy consumption in new homes, making progress towards our climate targets, and moving one step closer to net zero energy ready, the ultimate goal of the Energy Step Code. The energy step code for Part 9 homes has 3 performance metrics: airtightness, equipment and systems, and building enclosure. This slide shows how the step 4 metrics compare to our current step 3 requirements. As you can see, each of the 3 metrics have an incremental increase in stringency. Mary will speak more to what these mean from a technical perspective, but I will say what we are already seeing step 3 projects exceed the step 3 metrics and even at times achieve step 4. In particular, homes built with heat pumps as their primary space heating system are already achieving step 4 levels for mechanical energy use intensity. So now I will hand it over to our guest speaker, Mary McWilliam. Mary is a project leader with BCIT's Zero Energy Emissions Building Learning Center and has served as co-chair of the STEP Code's Capacity Building and Communications Subcommittee and has a wealth of knowledge on this topic, so we are very happy to hear from her today.
Thanks very much, Louisa. Thank you for having me. It's nice to be here. So I have a handful of slides and I promise I won't talk for more than 20 minutes. But I'm from BCIT School of Construction and the Environment, part of our Zero Energy Emission Building Learning Center. We've been around since about 2016, training builders, tradespeople, designers around the Passive House standard. And then when the STEP code came around, we kind of expanded to make sure we were covering that training as well. Next slide, please. The reset, would you be out? Oh, perfect, great. So I'm going to touch base on 4 things today, a bit about who we are, if you don't already know us at BCIT. What does that jump from step 3 to step 4 look like if you haven't already done that? Talk about some of the knowledge and skills, and then some of the courses and credentials that BCIT has been delivering for a while to help build that industry capacity. Next slide, please. Great. So we are a small learning center within the School of Construction. We've been around since 2016, as I mentioned. We do a lot of private training as well as our public courses. So we actually do more private training. So there's a lot of stuff we're doing that nobody really knows about. We host a lot of industry events and workshops. So you may have been to our lab or seen some of our science exhibits. And not only that, but we spend a lot of time supporting other programs, integrating this kind of training into our carpentry trades, our mechanical trades, our architectural trade programs, so that we're hopefully sending students out into the workforce that have new knowledge and skills needed to support this transition. Next slide, please. So you're meeting me today, but we have a large team. I have over 30 instructors that teach with me, and they all have full-time jobs in industry. So they are architects, energy advisors, building officials, builders, tradespeople, engineers, solar installers. They're part of our team. So when I share with you, what I come and share with you today is probably summarizing a lot of the knowledge that our team brings to the table. And this is the team that have helped build our curriculum and deliver our curriculum. So we're pretty sure it's current and help reflects the issues and practices in industry. Next slide, please. So when it comes to the knowledge and skills needed, we need new familiarity with the design features in our homes that affect performance, the performance metrics and compliance. I think a lot of you have run into that already. There's a lot of need to kind of make sure we're really familiar with building science issues and some of the emerging issues that come as we shift into more airtight buildings, buildings with less heat loss, and because the house as a system is changing, we're changing that dynamic. So making sure we've got current knowledge on building science. Design and construction practices. There's a lot of change there. You guys are already seeing that on the ground, but there's a lot of strategies to reduce risk and maximize value. from integrated design practices to new construction management, site supervision practices, and trades training. We do a lot of trades training because that seems to be one of the largest gaps that is needed. And then hands-on opportunities, whether it's for designers or builders and trades, getting a chance to get familiar with, sometimes the same materials in different assemblies or different details, or sometimes new materials, and how do we get there? So we're certainly aware of this, and I'll tell you a little bit more about that in the upcoming slides. Next slide, please. So step 3 to step 4, what's changing? A lot of you may have been building beyond step 4, which is fantastic. I'm just going to try and focus on this new change in case you haven't done that yet. Next slide, please. So Larissa already reminded you there are the 3 metrics. I'm going to go through them one at a time and kind of talk about what's changing for air tightness, then the building envelope, and then mechanical systems. Next slide, please. So air tightness first. I think you've already seen this, but we're switching. If we make this move from step 3 to step 4, we're moving from 2.5 air changes to 1.5 air changes. There's lots of concern over this. People who have been doing this for a while and have dialed their practices are actually finding this is not very challenging. So I don't want you to be worried about that. One of the things that the May 1st code update is allowing is some different air tightness testing metrics, which will give us a little bit more leniency if you're building smaller homes like coach houses and that kind of thing. If you're not familiar yet, those air tightness metrics are larger, are easier to achieve the larger the volume of your building is. So smaller buildings had a little bit more of a challenge, but that should be somewhat resolved with the May 1st code update. Next slide, please. So what's possible? Lots of homes are already doing this. There's an example in West Vancouver, the West Bay Passive House. We've got a full video case study on that, including lots of details on air tightness, but they're at 0.4 ACH. This smaller home in Vancouver, the next slide down on Point Grey Road, is at 0.19. This is a passive house in Moodyville. Probably lots of you are familiar with this. It's at 0.29 air changes. So even smaller homes, even though the top one isn't there, is a larger home, these can still achieve good air tightness. We've built things, standard air barriers with Tyvek and on garden sheds in our lab with lots of windows, doors, penetrations, and we're hitting air tightness levels that are 3 times tighter than passive, essentially on a garden shed. So it's just practice and skill. Next slide, please. So the trends, what are the new skills and things we've got to do here to get from 2.5 to 1.5? What builders and teams are doing is improving those architectural designs. Here's a sample of a drawing set. It's got a red line detail on it. So we've been really clear to understand and identify those air barrier details, work with the trades to figure out how to coordinate the trades interfaces, simplify those air barrier details, make sure we are clear going into a project. What are all the things we need to watch out for? We also see a clear shift to more resilient air barrier solutions. So air barriers that are not easily damaged during the course of construction, exterior air barriers, maybe more resilient materials in those air barriers. So thinking through that, that's one of the trends we're seeing. Next slide, please. Also an increased use of higher performance materials, sometimes some self-adhered air barriers. They're easier to install in adverse conditions, more resilient to damage. Site supervision, anybody who's hitting these high levels of air tightness have a really strong quality control aspect on site. Enhanced coordination of the trades, making sure that all the trades are trained and are aware what their scope of work is and how they interact with the air barrier strategy. And when I say this, these are the things that builders are doing out there, and they're hitting, tighter than passive house air tightness levels. So, start adopting these practices and developing these skill sets. And step 4 is certainly shouldn't be too challenging. Next slide. Thanks. So quickly look at the thermal energy demand intensity, so that building envelope metric. Switching from step 3 to step 4, we're seeing a reduction. We're going from 10% to 20% improvement in the building envelope. It seems like a lot. It's actually not that challenging in our climate zone. Next slide, please. This is something I wanted to draw your attention to. So BC Housing has been doing an energy step code market response study for a number of years now. This is based on their 2020-2021 survey about what builders are doing to drive down that TEDI. These are the most commonly used measures. Air tightness is the number one. It's the cheapest and most effective way at driving down your TEDI metric. Your energy advisors, I'm sure, are telling you that. Improving the insulation is the next thing. And then high performance windows and doors is in there as well. Next slide, please. So what is interesting to note is that the lowest cost measures are not the most frequently used measures. So this is a different chart, and do go and look at this because you can learn from builders around the province. Most of the respondents from this survey are folks who have already done this and they're building step 4, step 5, right, or beyond. But some of the strategies that are least deployed that can reduce your TEDI are optimizing that window orientation and simplifying the building form. So if you go to the next slide, I wanted to give you, okay. So a reminder, quick recap, when it looks at TEDI, we're looking at simplified architectural designs. So I mentioned simplifying the form. That's one of the easiest ways to drive down your TEDI. Improving your air tightness, improving the thermal performance of your windows and doors, more insulation, and trades training to make sure they can get these details executed correctly. Next slide, please. Next slide. Oh, perfect. I'm going to switch over to mechanical energy use intensity. So on the mechanical side, step 3 to step 4, and I think I might have skipped over a slide that I might mention. If I think about TEDI before I move on to MUI and thinking about those envelope performances, we have modeled a couple of different home types at every step of the step code in every climate zone. And what we find in our climate zone here, for a craftsman style home with a lot of articulation, dormers, bay windows, really not optimized in terms of form. You are able to hit step 5 of the step code just following the assemblies that you'd see in the 2019 Vancouver building bylaw. So slight improvements on your above grade walls, more insulation in your attics, below slab insulation, below grade insulation, beyond our code minimums, and we're able to get there. If you kind of scale that back to hit step 4, you can probably do it in a lot of non-optimized forms, right, with a more craftsman style home with complex form structure, just by improving your insulation levels and your air tightness levels without starting touching the above grade wall assemblies. So we know this is possible. We've modeled it for several homes. So that jump from step 3 to step 4 on the building envelope side, one of the biggest challenging things, if you haven't already done it, is hitting that air tightness metric. And the folks that have trained and developed a practice there are doing that without too much trouble. So the mechanical energy use intensity, I think I'll kind of skip over this. We've also modeled a couple different homes in all the climate zones, and how are they going to achieve the mechanical energy use intensity. It is going to be challenging for you to get to from step 3 to step 4, and especially step 4 to step 5, without using more efficient mechanical systems. So the air source heat pump or a heat pump solution for at least part of your systems is going to be needed. It seems to be the norm anyways in most projects. The builders that we're working with are all doing that, but that makes it really easy to hit your mechanical energy use intensity metrics. Next slide, please. So here, as I mentioned, we've done a comparison of a couple of homes. There's that at the top level here. This is this craftsman home, and complex form, slightly above code minimum assemblies to get to step 4. If you want to get to step 5, you're going to have to move the assemblies on that particular home up to the Vancouver Building Bylaw 2019 assemblies. The home and the bottom as a much simpler form. This particular home used, it overshot its air tightness targets, overshot its minimum assembly performance. So its TEDI was lower than it needed to be for step 4. But as a result, it was able to use any type of mechanical system it wanted. It could use a less than 100% efficient natural gas heating system, whereas the home above, without changing the form structure or doing some serious improvements to the thermal energy demand intensity, that home was not able to hit the mewing without an air source heat pump. So it's a bit of a lesson learned here to watch your form if you're looking at having any option possible when it comes to mechanical systems. Don't expect that to be the case, for a really complex form, unless you plan on overshooting some of the envelope requirements. So with an air source heat pump or heat pumps, no problem, nothing much is changing. But what is really important is good mechanical design and right sizing of equipment. It's important for cost, it's important for performance. So we've been spending a bunch of time focusing on this because of the issues that we're having. We can't just slap in systems without some better planning. There's some new knowledge and skill needed there to get a good mechanical design that will perform, and the house as a system will perform. So as we shrink that TEDI, being more thoughtful about mechanical systems is more important. Okay, next slide, please. I know, Browso, I'll just switch to the next slide. What people are doing to hit these are HRVs and heat pumps. Pretty straightforward. Go ahead to the next slide. And then one of the things that is the cheapest thing that is, the most cost-effective measure is right-sizing those mechanicals. We've done a number of studies, and the amount of new homes under the step code that have grossly oversized mechanical systems. So you're buying more expensive systems. They may not perform correctly because they're oversized. So being aware that right-sizing equipment and making sure contractors do that is one of the lowest cost and most effective measures. Okay, next slide. So how do we prepare for that? And I'll be really quick. Go ahead to the next slide. Our team of instructors who are out in industry, we're getting feedback, we're responding to issues. We have developed a wide range of learning topics, from air tightness and low TEDI assembly details to mechanical systems to site supervision, getting ready for proper planning on electrical systems to actually be net zero energy ready or start thinking about incorporating renewables, and embodied carbon and whole building life cycle assessment. So all of these learning topics are growing in importance and urgency, and we have courses to satisfy those, I guess, and develop those skills. Next slide, please. One of the things we pride ourselves on doing at BCIT is creating a lot of opportunity for hands-on learning. So we have a fantastic construction lab with a huge library of mock-ups where our students are building and testing their work. So builders come in, you can work with all kinds of different assemblies and products, test their work, evaluate details, and develop skill sets. So that's a good opportunity for trades training in order to kind of cut your teeth on hitting those higher air tightness levels in our lab and save yourself from learning on the job site. Next slide, please. One of the things we've also done at BCIT to help develop this skill set is create, a lot of our courses are live films, so you can attend from anywhere, which makes it easy, but we also have a huge library of technical how-to videos. So our builders and trades are pulling this stuff up on the job site on their phone when they can't remember exactly how to size a gasket and air tightness detail. you know, whatever it might be, to finishing trim around a window with outboard insulation. They're pulling up this library of how-to videos and making sure they capture the key elements to make sure it is airtight and thermally continuous, and they develop that skill set on the job site as well. Next slide, please. There's a lot of courses in lots of different categories. So if you are looking for training, you can probably find it here. There's lots of topics. We also have more courses here that aren't listed, but you can see from site supervision at the bottom to mechanical and electrical systems to building enclosures, and just getting a good grasp on the STEP code and what it means and how to plan and, you know, anticipate those costs and adapt your processes. We've tried to cover all that missing skill set and knowledge that our team of instructors have said is needed in the industry. Next slide, please. If you're looking for CPD points and learning units, we've got all of that as well. Go ahead to the next slide. We're seeing a growing interest in certifications, and we're offering a couple of micro credentials, so packaging up these courses into a bundle to recognize a consolidated skill set, or either around site supervision or essential knowledge or a life cycle assessment. So that is out there as well. What we have seen a lot of is builders or designers specifying these credentials or certain courses from their trades or from their team members to make sure that we've got the right skill set assembled on our job site for success. Next slide, please. Oh, and you know, we've got other professional certifications from the Passive House Institute that we can offer as well. Next slide, please. Lots of stuff. So our learning formats are online, hands-on, independent. There's job aids, there's videos, there's hands-on practice time, live interaction with that whole team of instructors. So lots of ability to transfer knowledge and develop skills to support these transitions. Next slide, please. And I wanted to point out to you two last things before I wrap up. We have a handful of open education resources. So if you go to bcit.ca/ZEB, you can find a handful of videos. There's a whole bunch of videos you can click on and access outside of any of our courses. So there's resources there. Next slide, please. And a last reminder, as you're developing the skills and the knowledge here, is our building codes allow us to, they're not leading documents, they react to research and experience. So picking up training or reading all these guides, there's a huge library of guides. A lot of them are free, but they will explain the emerging building science issues, the new skills, the new details that we need to be ready to adapt as we shift to these higher performance levels, whether it's for improving air tightness or shifting to higher performance assemblies and executing those details correctly. There's a lot of concern about some elements in our codes that, you know, don't enable the best building science. So do look towards these guides, because that's where that information is consolidated, and it takes years for that to affect the code, the prescriptive elements in the code. So go to those guides to continue your learning. And I think that would be my last slide, Larissa. There's one more maybe. Yeah, so there's my contact details. If you have any questions, feel free to reach out to me. We're always welcoming people to come and visit our lab, take a course with us. Let us know what you're struggling with, and we can certainly help point you to the right place to continue your learning. Thank you.
Great, thank you so much, Mary. So this concludes the presentation component of the workshop. So we will stop the recording now to move into our discussion time.